Hi guys, today let's discuss the LeetCode question 98, valid binary search tree. Given the root of a binary tree, determine if it is a valid binary search tree. So there are three conditions to determine if a binary search tree is valid. So the first one is the left subtree node value should be less than the current node value, and the right subtree node value should be greater than the current node value. And the last condition is the left subtree should be a binary search tree and the right subtree also should be a binary search tree. When these three conditions are followed, then it is called a valid binary search tree. So let's go to the example 1. So in the example 1, the current node value is 2 and the left subtree value is 1. So it is less than the current node value, so it is valid till the second step. And the third step is the right subtree value should be greater than the current node value, so that is also valid. So in this case, and the 1 and 3 doesn't have any more left and right subtrees, so that is the reason the example 1 is a valid and we are returning true in this case. Let's go to the example 2. So in the example 2, the same conditions will be followed as example 1. So the current node value is 5 and the left subtree value is 1. So it is less than 5, so it is valid till the second step. In the third step, the right subtree value should be greater than the current node value. So it should be greater than 5, but it is 4. So it is failed here. So we are returning it is not a valid binary search tree. We are returning output as false. And this one, this condition can fail at any level. So if it fails at any level, then we should return it as false. Okay. Let's go into the explanation part of it. Let's consider the following example. For a tree to be called a binary search tree, there exists a constraint on the tree node value. So let's look at the constraint, the lower threshold and upper threshold for each node. So low and high. So the low and high for this root node will be minus infinity and the high will be plus infinity. So it can take any value. And for the 2, the low is going to be minus infinity. It can take any value. And the high will only be 4 because that is the parent node. So it should always be less than 4. And for the one node, the low and high. So in this case, the low is again minus infinity and the high is equal to 2. And let's update the low and high for the remaining nodes as well. So for this, the low is going to be 2 and the high is going to be 4. The high is 4 because all this left subtree for this root node 4 should be less than the root node value. So the high will be 4 in this case. So let's update the low and high for the remaining nodes as well. So in this case, the low is going to be 4 and high is going to be plus infinity. Low and high. So the low is going to be 6 and the high is going to be plus infinity. And low and high. So the high is going to be 6 and the low is going to be 4 because all the nodes on the right side should be greater than the root node value. So that is the reason here it is 4 and the low can only be 4. Okay. So how are we going to solve this one? Now we come from the leaf tree node values and we check for each leaf nodes whether it is a valid binary search tree or not. So if we consider this one, it is a valid binary search tree. Why is it a valid binary search tree? Because the low can be from minus infinity to 2 and the tree node value is only 1. So in this case it is valid. The same goes for the 3 node as well. This is also valid. Then if the left tree is valid and right tree is valid and also the current condition is the low value can be from minus infinity and the high can be 4 and the current value is only 2. So this is also valid. So we mark this one also as valid. Then let's do that same thing for the right side leaf nodes also. So this one is valid. And same goes for this 7 node. It is also valid. And even for 6, this one also remains valid. So let's come to the root node. So the root node will be the left subtree is completely is a binary search tree and the right side is also a binary search tree. We are getting true from both the left tree nodes and the right tree subtree nodes. And the condition above is also satisfied. The value is 4 and the low threshold is from minus infinity and the higher threshold is to plus infinity. So the 4 is between this minus infinity and plus infinity. So this is also a valid valid binary search tree. So we return true in this case. I hope it is clear from this explanation. Let's quickly code this up. Let's start by creating a temporary function since we need the lower threshold and upper threshold. So let's create a function isValid, and we need the information like root and also the low threshold and also the high threshold. If root is none, so this is the edge case. If root is none, then we will be returning true. And then we are saying valid root. Valid root is equal to true if root.val is greater than low and root.val is less than high. If it is between this lower threshold and upper threshold, then it is a valid root, else it is false. Then we wanted to check if the left subtree is also a valid BST. So for that we are doing this is valid. We are recursing to that left tree. So it is root.left. Then we have to update the conditions lower threshold and upper threshold for the left subtree. So the lower threshold will be low and the higher threshold will be the root.val. So this will be the upper threshold because all the left subtree node values should be less than the current tree node value. And the right subtree, we wanted to recurse to the right subtree is equal to isValid of root.right. So we are recursing to the right subtree and the low value is going to be root.val and the upper threshold is going to be high. So we are not going to change the higher threshold for the right subtree. Then what are we should be returning the condition as true if valid root is true, if the root is valid and the left subtree is valid and the right subtree is also a valid binary search tree. So in that case we'll be returning it is a valid binary search tree. So what are we going to return? We are going to return is, so we are going to call this function is valid BST on, sorry, is valid on root, and we are going to pass the minus infinity and plus infinity as the lower and upper threshold. Minus infinity and the high is going to be infinity. Yeah, I think we are done. Let's quickly run the code. Yeah, let's quickly submit it as well. Yeah, it is submitted. Hope you liked the explanation. For more such videos, please subscribe to my channel. Thank you.